Hitler had made a fortress of Europe. The Allies were counting on engineering advances to help breach it. Rockets, a menagerie of specialized tanks, the world's first computer, and other technological innovations paved the way to the biggest invasion in history. Now, DDay Tech on Modern Marvels. Spring 1942. Continental Western Europe was under German control. Only England stood free. The English Channel was still an effective moat against Nazi aggression. Hitler had turned his attention to the Eastern Front and was in a monumental battle with the Russians. America, having just entered the war, and Russia were anxious to open a Western front, but the British were reluctant.
They had taken enormous casualties in World War I, and therefore Churchill had horrors about full-scale battles on the Western Front all over again. So they advocated what became known as the peripheral policy, which is you nibble away at the boundaries of the German Empire, continue strategic bombing, and that would be the best way to defeat Germany.
The British approach prevailed in 1942. A second front would have to wait.
It's fortunate because, quite frankly, we were building the army that was going to win the war, but it was only going to be able to do that in 1944. In 1942, we were a skeletal force. We didn't have the manpower, we didn't have the technology.
During the summer of 1942, a one-day raid along a 10-mile stretch of the French coast that included the town of Dieppe was organized to test Allied readiness to pull off an invasion.
It was primarily a British managed operation. It was a Canadian division with some Britishers and some American Rangers, and they attempted to storm the port of Dieppe in August of 1942. And it was repulsed with large-scale Canadian casualties and large numbers of prisoners of war taken, and the whole thing was simply a disaster.
The Dieppe raid proved that there was a certain amount of foolishness in attempting to capture one of the heavily defended, heavily fortified port cities on the English Channel coast.
Therefore, the idea was to land on a shoreline in a largely undefended region. Obviously, we know now that Normandy was the site that ultimately was chosen. But when you do that, you have to have equipment which is geared up to that kind of a job, and that's where in 1942 this kind of equipment was largely missing.
Even though there was no specific plan or timetable in place, the design and manufacture of the tools of invasion began. A disaster at Dieppe made it clear that to successfully mount a cross-channel invasion, it would have to be on a scale unprecedented in the history of warfare. It was up to the industrial might of America to mass-produce the enormous numbers of weapons, transport ships, landing craft, and vehicles needed to land on open beaches in France and confront the German army on the fields of Europe. American-produced equipment began to pour into England in staggering amounts. It was often joked that Britain was going to sink under the weight of the growing stockpiles. The British, not having America's capacity for mass production, focused on developing smaller numbers of specialized equipment, including an array of modified tanks created by the 79th Armored Division under the command of Major General Percy Hobart. These inventive contraptions became known as Hobart's Funnies, and many were designed specifically to help the invaders get off the beaches and past German obstacles.
Now, Hobart had designed different tanks to perform different duties, such as the Bobbin, which had this huge roll of canvas, if you will, could get off the landing craft and then unroll this mat. And across this mat, other tanks could follow. You can now navigate off soft ground or impossible ground that you couldn't otherwise move.
Another one were the fascines. These were tanks which carried logs. These logs were used to fill in tank traps so that the other vehicles could move along behind them. One of the most important of the Hobart Funnies was based on the Sherman tank. This was called the Crab. It was a flail tank. It had two projecting arms mounted to the side of the tank sticking out front, like the mounts of a bulldozer blade. And on this was a rotating drum. And on this drum were lengths of chain. And these chains would just fly, which is what they called a flail. They would flail around, and they would strike the ground with such force that they would explode German anti-tank Teller mines, just from the concussion of the hitting, so they'd clear a path in front of the tank.
Most of Hobart's machines proved too eccentric for the American Army. The only one they decided to use was the duplex drive tank. It was a Sherman tank with standard treads for driving across land, and a set of propellers that could be engaged to move the tank across water.
Of course, all of that's great, but the Sherman tank is a 37-ton vehicle, so even with propellers, you have to have a means of floating this thing. So what they developed is a canvas screen on struts that you can raise once the tank is about to go into the water. They had a wire frame, kind of like a 19th century hoop skirt. Once you're in the water, you can go at about 4 knots, which is not very fast. And the idea is to just get on land.
British inventiveness was also directed at finding a solution for one of the biggest problems of an open beach invasion: how to get tons of supplies and thousands of vehicles off ships and onto dry land.
The British came up with the idea of creating artificial harbors off the beaches. This was another benefit of the Dieppe raid. They knew we wouldn't catch a port real quick. We'd have to conquer it from the land, and we needed to have supplies coming in over open beaches for an extended period of time.
In the summer of 1943, construction began on 2 enormous modular harbors, codenamed Mulberries, that would be transported in pieces to Normandy once the invasion began. Their various parts were built all over England and Scotland. Huge concrete blocks soon appeared along the Thames River.
And German aerial reconnaissance saw these being built, and they had no idea what they were. They thought they were anti-aircraft forts. They didn't know what to make of them, and they never thought about an artificial harbor.
As work progressed on the Mulberries, the Western Allies continued to amass their equipment and train their troops for invasion. But meanwhile, Russia continued to take tremendous casualties in its epic battle on the Eastern Front.
In November of 1943, Franklin Roosevelt, Prime Minister Churchill met with Stalin at Tehran, Iran, to discuss post-war settlements, to discuss the Far East, for example, but also what came up was the invasion, the long-promised invasion. And Stalin repeatedly expressed doubts as to whether the Americans and British were serious about this. They had put it off so many times. And finally, it kind of came down to the matter, Stalin says, if you're serious about this, you will name a commander of this invasion. Have you yet? Which prompted Roosevelt then to make his decision to appoint Dwight D. Eisenhower as the overall commander of the invasion.
With Eisenhower's appointment as Supreme Commander of the Allied Expeditionary Forces, the planning for D-Day intensified. Codenamed Operation Overlord, it had a location, the French coast at Normandy, and a timetable, late spring of 1944. A major deception campaign was undertaken to feed the Germans misinformation about the time and location of the invasion.
They start Operation Fortitude, and the goal there is to convince the Germans of a couple of things. One, that we're going to land at the Pas-de-Calais, which is only 20 miles across the channel, and the other, that we have such a massive force that the initial landing, that's only just the tip of the spear. There's more to come.
A pretend army division was created, called the 1st U.S. Army Group. FUSAG only existed on paper, in fake radio traffic, and some specially built props.
We bring in set designers from the London Theatre and from Hollywood. Their job is to build fake trucks and planes. They have inflatable tanks which you can inflate, and all of a sudden in a field you can have a whole armored division, which you conveniently let a German observation plane fly overhead and see. and after the plane leaves, you can deflate this division, move it down the road, and inflate it somewhere else.
A great deal of effort went into the details of the Fortitude deception. But it was up to top-secret technology to prove the Germans were taking the bait. The secret code-breaking operations outside of London at Bletchley Park had been deciphering German radio messages, encrypted by the Enigma machine for most of the war.
Just a little after the outbreak of the war in Europe in 1939, British code breakers, with the assistance of Polish and French cryptanalysts, had managed to reconstruct an Enigma machine. Looking very much like an electric typewriter, the internal workings of the Enigma, its wiring, its rotors and wheels, was able to convert plain text into ciphertext as an operator typed on the keyboard.
But the German High Command often entrusted their communications to an even more complex encrypting device, the Lorenz machine. It produced an encoded message in the form of a teletype-style paper tape. In 1944, in time to confirm that the Germans were falling for the Fortitude deceptions, a new piece of equipment was installed at Bletchley Park. It filled an entire room with wires and vacuum tubes. It was the first programmable computer, aptly named Colossus.
What Colossus did was read 5,000 teletype characters per second from tape. And so it reduced the time needed to solve Lorenz from weeks into hours. This is your first true computer. In other words, the Second World War, the preparations for D-Day, ushered in the computer age.
Across the Channel, the Germans sensed invasion was imminent. Field Marshal Erwin Rommel, recently assigned the task of strengthening the coastal defenses, known as the Atlantic Wall, tried to cover as much of the coastline as possible, with a grotesque entanglement of metal objects designed to block the landing craft of an amphibious assault. Mines were attached to many of the objects in the water. Above the beaches were gun emplacements, ranging from simple machine gun nests to powerful artillery. Behind the beaches, some fields were flooded to entrap paratroopers. In others, wooden poles were erected to defend against glider landings. Allied reconnaissance of the Atlantic Wall defenses made the men of the invasion force aware of what they were about to face as they gathered at the airfields and loaded onto the flotilla that would take them to Normandy. D-Day was a tremendous gamble, but technologies were in place to help, including everything from ragdoll decoys to engineless aircraft and complex electronic trickery. On the night of June 5th and in the early hours of June 6th, as the Mammoth Armada began to make its way to Normandy for the biggest amphibious assault in history, the deception campaigns continued. In preparation for D-Day, strategic bombing raids had rained devastation on German defenses and transportation infrastructure, but special planning went into targeting radar installations.
Now, some of those radar installations were bombed, some of them were not bombed, because they were going to be used as a part of the overall deception plan that would convince the Germans that the operation was not going to come ashore in Normandy, but somewhere else.
In a brilliantly devised ploy, German radar technology was tricked into indicating that two fleets were heading toward destinations other than Normandy during the night before D-Day. One to Le Havre and one to Calais. To create the illusion of a fleet heading for Calais, a small group of Lancaster bombers of the 617 Squadron left an airfield in England in the middle of the night and headed across the Channel.
And what the 617 Squadron aircraft and their crews did was to fly in a very specific racetrack course, around and around and around, and each time that they went around in a certain direction toward the French shore, they advanced it maybe 500 to 600 yards. When they came to the point where they were heading straight toward the target, They would drop pieces of aluminum strips, which were called chaff in those days, or window. In consequence, you have virtually a shower of this chaff or window coming down and advancing at 8 knots, which the Germans knew was the typical speed that a convoy would make on its way toward an invasion.
When the Ghost Fleet got close to France, the planes pulled away, and boats below continued the deception.
The small launches put out all sorts of smoke screens so that the Germans couldn't see visibly what was going on. And then they had loudspeakers, and the loudspeakers made big clacking sounds as if anchors were being dropped into the water. They even had splashes, shouts of ensigns and so on giving orders, and it sounded as if a huge fleet was assembling out there, ready to make the invasion.
As the Germans were being duped into believing invasion fleets were heading to other landing spots, behind the coastal defenses at Normandy, paratroopers were dropping from the night sky. But only some of them were real. In another deception, called Operation Titanic, British-designed dummy paratroopers, nicknamed Ruperts, were being thrown from planes to draw the Germans' attention away from the actual drops.
Ruperts are very simple. They're a burlap sack that vaguely resembles a person, about 3 feet tall with a parachute. When you consider what a Rupert looks like, the idea that anyone would be fooled for very long was just meaningless. Although being a typical German, guarding the coast, start seeing parachutes with what appear to be people coming down, you don't necessarily go over to that field to look and see if the paratroopers have come down. You're more apt to go call higher headquarters and tell them you've got a problem on your hands.
Paratroopers weren't the only Allied forces to land behind enemy lines in the middle of the night. Gliders swooped down silently and deployed men and equipment to help destroy defenses and secure bridges.
Glider flying was very similar to paratroops, except we could carry in large equipment. We were able to get into places, small fields, beyond the enemy, into areas that planes couldn't land, and unload heavy equipment. We're talking about artillery, jeeps, and military equipment that's needed by the paratroops that already dropped in there.
Both British and American-built gliders were involved. The American CG-4A, also called a Waco for the company that designed it, consisted of a canvas covering over a steel and wood frame. To keep it as light as possible, it carried no defensive guns or armor. But that wasn't why it was nicknamed the Flying Coffin.
When the program started and they needed to have different companies manufacture CG-4A gliders, any company that had experience in plywood and fabric and so forth got a contract to make parts. And a lot of the companies were coffin makers, since they had the experience in making things out of wood. And so consequently, it got the name of Flying Coffin.
The Waco glider has a wingspan of 83 feet 8 inches. It has a length of 48 feet. It has an empty weight of 3,750 pounds. It's capable of carrying that same weight, which means that fully loaded, a Waco is carrying 7,500 pounds of weight for its wing.
With the Waco glider, the front end, the nose if you will open up. So now you basically have an open box with a ramp that you can drive a Jeep into or back up the Jeep into, or push an anti-tank gun or an artillery piece up into, block it and secure it, tie it down for flight.
The American CG-4A Wacos were towed into action by C-47 transport planes and attached by 300-foot-long nylon tow lines. The gliders used the same controls as a conventional aircraft: elevators, ailerons, and a rudder. The instrument panel on the glider consisted of only 5 gauges. They kept track of basic flight information, including airspeed, rate of climb, and altitude. While being towed, glider pilots had to be more concerned about their relationship to their tow plane than their gauges.
Normally, in flight, the C-47 is flying just below where the glider is. The reason being that if you're down behind it, you're in his prop wash, and so you're kind of flopping around. So if you're flying above, you're out of his prop wash.
The lines of communication between the glider and the tow plane utilized cord that ran along the tow line for the simple reason that radio communication is interceptable. And anytime you have radio communication between two planes, that means somebody on the ground can be listening in on you.
The audio cable running alongside the more elastic tow line was often damaged, and communications between planes cut off. It wasn't a critical failure, because the most important message from the C-47, the order to release from the tow line, was delivered in a fail-safe way.
They signaled us with a light out of their dome in the C-47. They gave us a signal. We had about 10 seconds, and then which was a red light, and then the green light came on, and we cut loose. And you didn't want to hang past the green light, because if you did, they'd cut you loose.
The Waco glider was quite maneuverable, but carried a maximum passenger load of only 13 fully armed men. The British Horsa glider could carry double the cargo, but its design had its own drawbacks.
The Horsa, having a wingspan only 4 feet larger than the Waco but weighing twice as much, means you've got a higher wing loading. That means you've got more weight per square inch of that wing, and in order to maintain flight, that means you've got to fly faster, and you come in faster and harder.
Many of the gliders, British and American, suffered severe landings. There was less moonlight than hoped for, and the fields were smaller and lined with more tall growth than expected. Even though almost all of the planes were damaged, most of the men and equipment managed to survive. The troops carried out their missions to capture objectives and hinder the Germans' ability to respond to the invasion forces that were about to tear into the beaches with the explosive technologies of bombs, artillery, and a device to hand-deliver TNT. Dawn, June 6th. The amphibious assault of Normandy, codenamed Neptune, had been delayed by 1 day because of storms. The seas were still choppy, and the weather far from ideal. Allied bombers roared overhead in a final attempt to weaken German coastal defenses, but many missed their targets due to the low cloud cover. Then it was the fleet's turn to open fire. Warships and the fearsome new technology of landing craft armed with over 1,000 rockets each bombarded the coast. The goal? To knock out enemy guns, blow holes through beach obstacles, set off mines, and kill or unnerve as many of the enemy as possible. It was the 1944 version of shock and awe. During the deafening barrage, men clambered off the transport ships into smaller landing craft that would take them to shore. When the Allied guns halted, it was time to hit the beaches. The British came ashore at Gold and Sword, the Canadians at Juneau, and the Americans at Utah and Omaha. The men at Omaha had it the roughest. Many of the German obstacles and gun positions had survived the opening air and naval barrages.
One of the units first ashore are the amphibious engineers, and their job is to go ashore and blow gaps through the enemy wire. You know, here the Germans have laid strands of barbed wire entanglements up and down the beach, where your men can't just run through that. So they have to take out the wire. How do they do that? Bangalore torpedoes.
Bangalore torpedoes. 5-foot lengths of 2 1/8-inch diameter pipe, packed with explosive, were simple yet effective.
They're light enough that a man could carry 1 or 2 pieces, and so a squad or a platoon could carry a number of pieces. And when the path was needed through a barbed wire entanglement, You put on a nose cap, and you kept pushing ahead, pipe after pipe after pipe. Put a blasting cap in your last piece of the Bangalore torpedo, set it off. The steel from the pipe, as well as the explosion, would blow a gap right through the barbed wire and also explode any mines in the gap. And that gave you a way to move forward.
Once beyond the barbed wire, the Allies used 10-foot wooden rods with TNT attached to one end, called pole charges, to take out enemy bunkers.
And the idea here is if you want to blow a hole through an enemy bunker, the assaulting infantryman or engineer has to run up under fire to the bunker, place the pole up against the bunker, knock one end firmly into the ground, and as he does that, the hinge plate will swing up flush with the bunker. And here you have all these blocks of TNT now firmly against the bunker. At that time, if he hasn't been killed by the Germans, we'll set the fuse and run like hell, at which time the pole charge will go off and hopefully blow a hole through the enemy bunker.
Bringing the men to shore at Omaha was the smallest of the landing craft used that day, the LCVP. Each one carried just 36 men, but the flat-bottom boat rode high in the water, got the men past many of the submerged obstacles, and delivered them right up to the water's edge.
The 36 men inside the squad bay could stand upright with packs on their backs, rifles in their hands, and when the boat beached itself and dropped the ramp, they could unload from the boat in a very, very short space of time. They could be off and in the battle.
The LCVP, also known as the Higgins boat in honor of Louisiana shipbuilder Andrew Higgins, was an adaptation of a pre-war swamp boat he designed for use in bayou country.
Higgins designed boats that were particularly adept at operating in shallow tributaries, in other words, swampy areas. And because of this early experience in designing boats that could operate effectively in shallow water, it was really a very simple transition for Higgins then to begin building boats that were capable of landing assault forces.
It's got a big 6-cylinder gray marine engine in it with a twin-disc transmission. The transmission's really unique in that it can go from forward to reverse at full power. This allowed easy reverse from the beach, so the boat could get off the beach once it dropped its load and go back and bring in more troops.
The prop design of the LCVP was a channel prop that ran down through the hull and had a protective keel spine that ran out to the back of the boat. So the prop was somewhat enclosed and protected. It has an iron ramp in the front that was lowered by a series of winches and pulleys that were in the inside of the landing craft. But the hull of the landing craft was made of marine mahogany. It's basically a wooden boat with a steel ramp.
Higgins Industries in New Orleans worked around the clock with a workforce that grew to 30,000 men and women to supply nearly 20,000 boats for the war effort. The importance of the boats that Higgins built was best summed up in the words of General Eisenhower. If Higgins had not designed and built those LCVPs, we never could have landed over an open beach. The whole strategy of the war would have been different. With the first wave of men gaining a foothold on the beaches of Normandy, the next wave of machines, from huge cavernous landing ships to strange hybrid vehicles, was about to rumble ashore. The afternoon of June 6, 1944, the German beach defenses at Normandy had been overwhelmed by a potent mix of advanced wartime technologies and bravery. An astounding number of landing craft and supply ships converged on the coast of Normandy. Their job? To start unloading the equipment and men needed to establish a beachhead and prepare for the push inland.
When I looked back from the beach to the channel, the sea, I was shocked by the number of crafts and ships. I couldn't see the horizon. There were battleships and cruisers and all kinds of landing craft coming in and going out. And I remember thinking at that time that this is the high point of my life. This is a tremendous operation.
Over Over 5,000 vessels took part in the landings at Normandy. At 328 feet, the American-built LST, or landing ship tank, was the biggest.
It had a drive-on, drive-off capability. What this did was it made it possible for the LST to take on a load of vehicles that could be everything from 2.5-ton trucks, or they could even be a platoon of Sherman tanks.
The LST had 2 decks. The lighter vehicles were loaded onto the top deck, while the tanks and other heavy equipment stayed below. The craft's flat bottom enabled it to slide right up to a beach.
The ballast tanks could also be adjusted so that your bow could be raised somewhat and the stern lowered a little bit, so that when it came into a Normandy shore, for example, it would be sort of like a goose landing slowly, tilted somewhat backwards, and you could come in closer for the offloading of your equipment.
Once beached, the LST's large clamshell doors were opened and the ramp lowered for the quick unloading of its enormous cargo. If the angle of the beach kept the huge LSTs from getting close enough to shore, rhino ferries were used to haul the equipment to land. Built specifically for D-Day, they were 41 feet wide and 176 feet long and made from steel pontoons. They were powered by 2 large outboard engines. LSTs were equipped with a dock that rhinos were able to latch onto.
You could actually drive this pier up to an LST, open the doors of the LST, lock on with the rhino barge. The tank could drive right onto this barge, and the rhino barge could take the tank dry right to the beach.
When they crossed the channel with the invasion fleet, each rhino ferry carried its own bulldozer. Offloaded on the first trip to the beach, the dozers would build sand ramps to aid in unloading and help push the barge back to sea if it became grounded. Another of the indispensable transports used at Normandy was a half-truck, half-boat that could do the job of both.
In 1942, General Motors, which was building the Deuce and a Half, the 2.5-ton truck that was the backbone of our Army transport, decided to come up with an amphibious version. It was given a corporate designation of DUKW, but anything named DUKW was quickly dubbed by the Army Duck.
The 31-foot-long vehicle was shaped like a boat and had a hollow, airtight body for buoyancy. A single propeller provided the duck's momentum in the water, while it used 6-wheel drive on land.
It had the same 6-cylinder engine that was used in the Deuce and a Half truck. It was a heavy-duty truck engine, very powerful. On road, it could give you the same performance as a truck. It could go 55 miles an hour. It wasn't wise to go that fast, but it would cruise all day at 35 without any trouble. On the water, it would, depending on the water conditions, it would go 5, 6, maybe 8 knots. It was not a speedster. It was not meant to be.
With their ability to transport weapons, troops, and supplies from offshore ships directly to supply depots or fighting units, ducks played a vital role in the complex logistics at Normandy. When enough armored vehicles and men were unloaded on the beaches of France, the invasion force began to penetrate the French countryside. Here the troops encountered natural obstructions that proved to be as problematic as any of Rommel's contraptions on the beaches. Hedgerows.
A hedgerow, it's an extended shrubbery that's been growing for about 600 or 700 years. And it's usually, although not invariably, but a lot of times, the basis for it was a crumbling stone wall.
The problem with the hedgerows was that if you tried to scale them by tanks, the tanks moving up and over them, some of them 8-10 feet tall, it exposed the tank's soft underbelly and made them easy targets for German anti-tank weapons.
If Allied tanks couldn't go over or around the hedgerows without being exposed to enemy fire, the only choice was to find a way to plow through them. The solution was created by the men in the field with a makeshift modification made from scavenged metal parts.
Well, you just take a steel plate and you weld the prongs to the bottom of it, and it's fixed on the tank. And you get it down low enough so the tank can get underneath, basically scoop and just pull the stuff out above the roots, just like you would do if you were clearing brush. To me, a lot of this is what we call spontaneous innovation. I mean, the biggest innovative force that we've got is basically just ordinary American soldiers who are coming from civilian life, and they're trying to solve these problems.
This sort of on-the-spot ingenuity gave the Allied forces the edge on a day-to-day basis. But two mammoth long-term engineering undertakings, built in secrecy, would help guarantee that the D-Day landings were just the beginning of the liberation of Europe. As Allied men and equipment inundated the beaches of Normandy, the Germans still thought that the D-Day landings might be just a diversion for the real invasion force yet to come. It just didn't make sense to land where there wasn't a harbor to facilitate the unloading of all the men and materiel necessary to gain a foothold in France. Little did the Germans know that a pair of the biggest secrets of the war, the two portable harbors named Mulberries, were being towed into position. Mulberry A would serve the American landings at Omaha and Utah beaches, and Mulberry B would be assembled off Gold Beach by British forces. In the rough seas of the Channel, an effective breakwater was the most vital part of the puzzle that made up the Mulberries. It was for this purpose that a series of up to 200-foot long and 50-foot wide concrete caissons, codenamed Phoenixes, were built.
They brought them across the English Channel by large tugboats, positioned them where they want to have the breakwater, and smaller tugboats would position them very accurately. Then they would open up the sea valves underneath them and sink them. Of course, they had to know the depth of the channel there, which I understood that the Royal Engineers had all that surveyed.
To create secondary breakwaters on the outer edges of the harbors, old ships were scuttled.
Along the areas that they wanted to protect, they sank merchant ships, old battleships, anything they could find that they didn't need anymore. Some of the ships were sunk in relatively shallow water so that the decks were still above water, and they were manned with anti-aircraft guns and crews for a period of time after the invasion.
To provide a dock for ships to unload on, steel rectangular floating pierheads were built, with legs that allowed their platforms to rise and lower with the tides. Each Mulberry utilized 6 miles of flexible steel roadway. Flotation was provided by steel and concrete pontoons. This enabled the men and equipment being unloaded at the pierheads to drive over the water and arrive on dry land. On June 12th, after only a week, the American and British Mulberries were operational.
And we could unload a huge amount of material just as if it was a natural port or harbor. It was one of the most creative things that we did during the D-Day invasion.
But after only a week, disaster struck.
The worst storm in 40 years came up and began to immediately cause casualties and damage to resources, most importantly to Mulberry A. The storm continued for several days, and the outer floating seawall started to break apart. Big pieces of this began hitting against Mulberry A and damaging and ultimately destroying most of it.
The American Mulberry was beyond repair, and the British Mulberry was badly damaged.
The Allies have lost half of their port facilities. So what they do is they take what's left of Mulberry A, the American Mulberry Harbor, they bring it over to the British beaches, Mulberry B, to help build that harbor back up and get that functioning again.
There was one more major technological challenge for the Allies to meet: how to guarantee a steady supply of fuel to the mechanized armies landing in France. The innovative solution was called Pluto, short for pipeline under the ocean.
In building an undersea pipeline, which is what they had to do, they had to come up with new technology. And rather than create something wholly new, they went to what they knew worked, which was undersea cables, transatlantic cables, which were flexible cables that were in short segments connected and protected by a rubberized coating.
For Pluto, 3-inch diameter steel and lead pipes were welded in lengths as long as 30 miles. They were wrapped in a protective and flexible coating that included layers of paper, steel tape, and steel armor wire. The entire project was ready by D-Day, but deployment was delayed for nearly a month because the Allies had difficulty capturing the planned destination site, the port city of Cherbourg. The heavy German resistance finally gave way on June 27th, but the Germans destroyed much of the port before relinquishing control. When Cherbourg was sufficiently rebuilt to receive Pluto, it only took about 10 hours to lay the pipelines across the 70 miles of channel. The lead pipes were deployed from the holds of ships, while the steel pipelines were unrolled off huge floating drums called conundrums. The first Pluto pipeline became operational on August 12, 1944. During the next several months, over 500 miles of pipeline were laid across the channel and over land to keep pace with the forces as they made their way east. Even though one of the mulberries had been destroyed by a storm and the initial laying of the underwater pipeline had been delayed, these two engineering marvels helped the Allies ride toward victory. They joined all the new machines, electronic trickery, and scientific breakthroughs as part of the Herculean effort that went into the success of D-Day.
Technology was an important tool to achieving victory, and it was necessary because without the technology, the cemeteries that overlook Omaha Beach would have been much larger than they are.
It still stands alone among the world's great military enterprises as a vast, complex, and nevertheless a human endeavor.
With the D-Day landings, the Allied invading force had successfully breached Fortress Europe, would soon liberate France, and then roll toward Berlin. The technology the Allies developed for the ultimate military assault helped give them the advantage and change the direction of the war.
Which is what they called a flail. They would flail around, and they would strike the ground with such force that they would explode German anti-tank Teller mines, just from the concussion of the hitting, so they'd clear a path in front of the tank.
Most of Hobart's machines proved too eccentric for the American Army. The only one they decided to use was the duplex drive tank. It was a Sherman tank with standard treads for driving across land, and a set of propellers that could be engaged to move the tank across water.
Of course, all of that's great, but the Sherman tank is a 37-ton vehicle, so even with propellers, you have to have a means of floating this thing. So what they developed is a canvas screen on struts that you can raise once the tank is about to go into the water. They had a wire frame, kind of like a 19th century hoop skirt. Once you're in the water, you can go at about 4 knots, which is not very fast. And the idea is to just get on land.
British inventiveness was also directed at finding a solution for one of the biggest problems of an open beach invasion. how to get tons of supplies and thousands of vehicles off ships.
So they advocated what became known as the peripheral policy, which is you nibble away at the boundaries of the German Empire, continue strategic bombing, and that would be the best way to defeat Germany.
The British approach prevailed in 1942. A second front would have to wait.
It's fortunate because, quite frankly, we were building the army that was going to win the war, but it was only going to be able to do that in 1944. 1942, we were a skeletal force. We didn't have the manpower, we didn't have the technology.
During the summer of 1942, a one-day raid along a 10-mile stretch of the French coast that included the town of Dieppe was organized to test Allied readiness to pull off an invasion.
It was primarily a British managed operation. It was a Canadian division with some Britishers and some American Rangers, and they attempted to storm the port of Dieppe in August of 1942. And it was repulsed with large-scale Canadian casualties and large numbers of prisoners of war taken, and the whole thing was simply a disaster.
The Dieppe raid proved that there was a certain amount of foolishness.
Hitler had made a fortress of Europe. The Allies were counting on engineering advances to help breach it. Rockets, a menagerie of specialized tanks, the world's first computer, and other technological innovations paved the way to the biggest invasion in history. Now, DDay Tech on Modern Marvels. Spring 1942. Continental Western Europe was under German control. Only England stood free. The English Channel was still an effective moat against Nazi aggression. Hitler had turned his attention to the Eastern Front and was in a monumental battle with the Russians. America, having just entered the war, and Russia were anxious to open a Western Front, but the British were reluctant.
They had taken enormous casualties in World War I, and therefore Churchill had horrors about full-scale battles on the Western Front all over again.
Including an array of modified tanks created by the 79th Armored Division under the command of Major General Percy Hobart. These inventive contraptions became known as Hobart's Funnies, and many were designed specifically to help the invaders get off the beaches and past German obstacles.
Now, Hobart had designed different tanks to perform different duties, such as the Bobbin, which had this huge roll of canvas, if you will. Could get off the landing craft and then unroll this mat. And across this mat, other tanks could follow. You can now navigate off soft ground or impossible ground that you couldn't otherwise move.
Another one were the fascines. These were tanks which carried logs. These logs were used to fill in tank traps so that the other vehicles could move along behind them.
One of the most important of the Hobart Funnies was based on the Sherman tank. This was called the Crab. It was a flail tank. It had two projecting arms mounted to the side of the tank sticking out front, like the mounts of a bulldozer blade. And on this was a rotating drum. And on this drum were lengths of chain. And these chains would just
in attempting to capture one of the heavily defended, heavily fortified port cities on the English Channel coast.
Therefore, the idea was to land on a shoreline in a largely undefended region. Obviously, we know now that Normandy was the site that ultimately was chosen. But when you do that, you have to have equipment which is geared up to that kind of a job, and that's where in 1942 this kind of equipment was largely missing.
Even though there was no specific plan or timetable in place, the design and manufacture of the tools of invasion began. A disaster at Dieppe made it clear that to successfully mount a cross-channel invasion, it would have to be on a scale unprecedented in the history of warfare. It was up to the industrial might of America to mass produce the enormous numbers of weapons, transport ships, landing craft, and vehicles needed to land on open beaches in France and confront the German army on the fields of Europe. American-produced equipment began to pour into England in staggering amounts. It was often joked that Britain was going to sink under the weight of the growing stockpiles. The British, not having America's capacity for mass production, focused on developing smaller numbers of specialized equipment.